So we're back. Sorry about that. It's just a little confused, honestly. Can you hear me now? Is everything clear? Good? Can you see everything? AutoCAD, blah. Okay. So fine. Okay, we were talking about the materials that is used for wardrobes, which are your 6 mm, 12 mm, and 19 mm plies. There are different grades of plies and stuff like that, but we'll deal with that when we're talking about kitchens. For now, we don't care. So with these particular thicknesses of plywood, we have a few different pieces of pieces that we need. Uh, the shelves, obviously, there's a backing panel also, but the most important thing that we are going to be dealing with is are the doors. All right, the door is by far the most important design factor of this particular wardrobe. So just drawing an elevation here, projecting that up, XL horizontal, offset by let's say our floor to floor is 3000 or 300. This is in centimeters, sorry. So 300, and let's say our slab on top is 15 centimeters. Our slab below is 15 centimeters also. So this is approximately our elevation. Let's trim this. So this would be the elevation of our well of our wardrobe. The point is the size of the door, the placement of the door changes the elevation. And when I say that, I mean things like, assuming I was to have three doors for this thing. All right, yeah, I'll get to the sizes of the doors later. But as of now, let's assume that we have three doors. So let's say let's draw this in blue. No, why not? So it's a little clearer. So we have that. Let's assume that we use 19 mm ply here. E, sorry, 1.9. So those are our doors, and let's say we want to divide this by 3. So let's say div 3, enter, no, line 1 point, there's the other point here. So we have 3 doors, right? And oh, please keep typing stuff in the chat, just so I know everything is clear, that you're understanding. Just, and don't keep saying yes, 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 because all the questions I ask can be replied to with yes. So say, huh, we understand the size of the doors, or something like that, please. All right. So yeah, so in this particular thing, I have 3 doors that I've drawn. And so in our elevation, what it'll look very simple. Vertical. So this is what it will look like, right? So basically, this is one option. The but where does the door actually fix onto, right? How does it actually swing, and how does the hinges work? That's basically the most important thing that you need to learn in a wardrobe sheet, I think. So let's draw these doors as rectangles, and let's say rotate around that point. Take off F8, so it turns around there, yes, which is all good and nice. So that stops there. Another rectangle for the second door, rotating about that point. Again, take off F8, so that opens, and then rectangle along this point, and rotate about there. Uh, so who sees the issue right now? Who sees that there's a problem? Oh, and yeah, Shriyamdar, yes, the height I've taken is up to the ceiling. We'll get to those details in a bit. Let's just deal with the door widths for now. But yes, so who spots the problem with this particular arrangement right now? The hinges and things like that. The third door is this one as of now. The overlap. The overlap here basically means that this door has to kind of go into this the other door for it to work, and that doesn't, well, we obviously can't have that. So the way we deal with that is by the clever use of hardware, right? And the hardware that we need to talk about. Sorry, that we need to deal with are the hinges. Okay, so I'm just doing a basic Google search for wardrobe hinges. So that should give us something. Yeah. So with this is the regular hinge that you're used to, yes? I'm just holding on, just waiting for you people to respond to this because it's kind of important. So this is your regular pin hinge, or whatever you want to call it, but this is what was used, and in the example that you people or the example that you sent me, the sheet, this is probably the hinge that you're going to use, and there isn't any problem using this particular hinge, except for the fact that you can't do this. Uh, we'll use that particular hinge for now. So that hinge fits in here perfectly. So this door, there's no issue. This door, on the other hand, has to move. So let's move this here and this here approximately. But still, you need some kind of support, something for these hinges to actually, well, be connected to. And for that, we'll need, let's say, another 19 mm ply along the vertical axis here. So what's 19 divided by 2? 19, 9.5. Let's I 0.95. 0.95 that way, 0.95 this way, and extend this to there. No, there and there. So as of now, we have one partition here and we have a double partition here. This particular door, to use that particular pin hinge, will have to be connected here, right? Only then does it actually work. Same thing here. So this door will have to move here, correct? Obviously, the size of the door right now won't it's as in I haven't changed the size of the door, that which also will have to. Right? Does everybody get this idea of why the door has to move to this particular point? Hello. I'm waiting for your responses on why you think we need to move the doors here and things like that. Just so I'm pretty sure that you understand this pin hinge, because if you don't understand the pin hinge, there's no point moving ahead, as in it'll be very very confusing. The plywood support is, yes, required for the hinges obviously, but the reason that we need to move it, because okay, actually, yeah, the reason we need to move it is not just for the plywood support. Obviously the plywood support exists for whichever type of door, I mean whichever type of wardrobe we use, because this is one section, this is the other section. So we need something, as in there's another reason why these doors have to be moved here. And it's, yeah, the overlap that we'd spoken about earlier. And the pin hinge obviously works along one particular point, along that point. So it'll go this way and here, right? Now, all of this is well and good. Again, this is a okay wardrobe. There are no issues with this. The problem is with the elevation. The elevation doesn't. Oh, wait. The elevation doesn't look like this anymore, right? What is the change that we'll see to the elevation? Yes, a double line. All right. So drawing that double line, sorry, XLV would be one point here and the other point there, right? And the center line goes trim from the top to the bottom here, right? So this is what our elevation suddenly becomes, which is not as clean as it was earlier, right? Earlier it was just the three doors, nice, happy, but that didn't work. So we need to do this one extra band in between as a support, right? So that becomes a frame, kind of a frame, at least on one side. And depending on how we design the rest of the structure, we'll probably have frames as in this frame all around and things like that. Possibly if you put another plywood thing here to fix the hinge, then yeah, you'll have a frame here, then you'll have another frame here, and so on. The point is these edges will have to be designed also. And when I say designed also, I mean the material selection will have to be, as in you get tapes and things like that you can put for that, or the carpenter might have to cut a very thin strip of laminate to stick onto that and things like that, which are generally not very clean finishes, as in it is done, has been done for a very long time, but it's not a very clean finish. And the way we get around that is by the clever use of hinges. And the hinges that we are talking about is, okay, I'm going to just say wardrobe hinges types, which would give us a picture which is nice. Is it nice? No, it's not nice. Ah, is this? Okay, let's use this one. Visit page. Ah, perfect. So the hinges that we are planning to use, or that you need to understand or learn about, are these three things. All right. There are three types: the full overlay, the half overlay, and the inset hinge. All right. Now these three hinges are, well, the pictures of them are here, obviously. These kind of things. So you'll notice that it's obviously a lot more complex than your regular hinge, and there's a reason we need that complexity, right? So let's start with the full overlay. All right, I'm just going to draw this into the drawing here. Obviously, I'm not going to draw the actual overlay. I mean, the actual hinge itself. I don't have that much time, honestly. Uh, let's first of all move this particular frame by 2 centimeters back. Let's add a couple of extra frames to the sides for our support. Let's trim it decently to the outside trim. Delete that. Delete our three doors. Offset 1.9. So this is approximately what we want our wardrobe to look like. I haven't drawn the backing ply, we'll do that later. For now, this is the kind of elevation that we want. But where does this particular, actually let's do this side first, the full overlay. So this door is here, right? So if I was to draw this as a rectangle, it comes and fixes here. Let's give that extra thickness, or no, not color. Let's do extra thick. Yeah. So actually, let's give it a different color also. Why not? Let's say green door. So this particular door has to fit here. This is the support. You'll, if you put a pin hinge anywhere here, the door simply won't even open. Right? The mechanism simply won't allow for a pin hinge to open. But the idea of a full overlay hinge, which is this particular one, you'll notice that the door comes till here and the rest of the hinge stays there, right? And that is connected to the side of your wardrobe and things, and this particular thing actually goes into the door itself. Actually, we should we have YouTube, so let's actually look up a overlay hinge video. Why not? I don't know how to explain this stuff. I just realized I could probably ask you people to YouTube or Google this stuff and you're done, no? I really don't have to do this at all. But, okay, ignoring all of this blah. Where's the hinge, man? Let's. Overlay. A decent opening. Operation is a good word. Really? There's not one video of them just opening it. Oh, come on. Okay, let's just look at the adjustment. I'm pretty sure at some point he'll open the door. Okay, wait. Do we need volume for this? Not really. Oh, he's explaining adjustments and things like that. So you're going to open, close the door at all. Mechanism. That's a good word. Okay. I'm gonna try full overlay cabinet hinge. That's actually a much better search term. The difference is, okay, I'm just gonna, if this works, Uchu intro. Okay, Roxla slice. Okay, why that is happening. Okay, so this works. This is what Kiran's found. should check out the drill and all. But these are the obviously the different parts of the particular hinge and how you fix it, which you're not, as in you can obviously watch the video yourself. I just want to show. So this is what it looks like when it's installed. So one portion is here, the other the main portion is here. This part is actually goes into the door itself for a slight bit. This part is kind of like on a pivot plus a telescopic hinge, which is a slightly weird mechanism. But let's see if they open this. Please open it. Okay, but yeah, here he shows the elevation with the doors fitting perfectly next to each other and things like that. Does he open it anywhere? No, come on. Okay, I'll find a video for you later. I think I took a video, so I'll have to look for that. But anyway, I'll find one and post it somewhere. So the idea is that this particular door does not just turn around one of these points, right? It doesn't just turn like that. As in, it doesn't turn like that because a hinge is placed here. A hinge is placed along this point, and this mechanism allows for it to finally open into this kind of a position where this goes slightly back, if I'm not mistaken. All right. So since this is allowed with this overlay hinge, where's that? Images. Yeah. So since this is allowed by our overlay hinge, our elevation now becomes perfectly clean, right? At least in this edge, we don't have another, we won't have another frame on this side. Now to talk about this frame in the center. If we try doing the same full overlay thing here, let's say we start here, obviously, move it there. Let's color this also green for the time being. This, if this here door is placed like this, what happens to this door, right? So that's going to be a problem. So what we need to do is obviously share the partition. What we do here is move it to the to approximately half, I mean not approximately, exactly halfway. So 0.95 F8 enter. Yeah, so that stays there. And here we use the full I mean the half overlay, right? So this uses kind of half the support, or it doesn't cover the full gap. Okay, there's a 3/16 of a gap and things like that. That's mostly just to keep some clearances. And you'll realize that in architecture, nothing finishes in a paper joint. And this is important, right? So once you have a half overlay on this side, the other door will obviously, not this side, slightly smaller. The other door obviously moves into this position, right? And they have a slight gap and stuff like that. But the point is, in our elevation, the frame behind it or the support behind it is now hidden. Our elevation, instead of it being two separate lines there, if we can assume that the 3/16th, oh wait, what did I do? I deleted a lot of stuff. Okay, if we assume that the 3/16th or something is tiny enough to be seen as one line, then our elevation is back to our very clean 3-line kind of thing, and we are sorted, right? So this is the most important thing about wardrobes and wardrobe hardware. So we have 3 types of hinges: the full overlay here, the half overlay here. But what's an inset hinge? Obviously, I personally like this kind of finish. It's clean. There are no extra lines. There's nothing else. It's just 3 lines and you're done. Possibly, what's this? Just a nice clean handle there, and you're sorted. But obviously, we need to provide the option where that frame is still visible. Say that's part of your design. So what we do there is use a hinge called the inset hinge, and the inset hinge is used when we want this kind of an elevation. So the door is here, this door is along this line, right? And if we were to look at our picture again, this is what an inset hinge looks like. So this is our cabinet support, this is the door itself, and this is the hinge. You'll see that in the elevation here, as in obviously we're standing here and looking at this, in the elevation we'll see this line, right? So if you were to let's just go back here, obviously this particular line will be visible if you use an inset hinge. So these are the three types of hinges that we're talking about: the full overlay, the half overlay, and the inset hinge. All right, does everybody understand this? This is kind of the whole point of this sheet. Mostly there are a couple of other hardware things that we'll talk about, but this is well, the most important thing, because the hope is that you'll use this for your kitchens, you'll use this for your TV cabinet, you'll use this for your office workstations. It's basically the same hardware, right? So please tell me if you understood it clearly. I sent you a video of the hinge on WhatsApp. Okay. Okay. While you people answer that, I'm going to start looking for this, for the video of this thing, because I did take a what's this video of it. I remember this is from one of my sites, so finding it is going to be a pain. No. I think I found the set of things. I did. I did. I did. All right. So this is a video I took of this particular hinge. Wait, stop. Wait, pause. On one of my sites. So you'll see here that this is a half overlay hinge. Obviously, there are things on that side. There's like a middle support of one of the cabinets. This is a kitchen, but it's basically the same hinge. So you'll see that it's a complex mechanism of how it works, right? But you see where the door ends up, and where it actually, yeah. So this is a even more complex hinge, which I'll explain in a bit in terms of the angle that it's used in. But just for you to understand what the mechanism actually looks like. I wonder if I have any other videos. No, just that. So yeah, so this is what that hinge looks like on in one of my projects. Oh, jeez, I've gotten a lot of messages. Sorry, we'll reply later. But yeah, with this, does everybody understand what these hinges do, what the point of them is, why it is there, why these hinges needed to be invented, why you need to learn about it, all of those questions? I randomly had two videos running in the background. So yeah, let's close these things up. Just let this run for the while. Check it out, the Ishtal presentation and all. I wonder, as in, imagine the guy recording the video of himself just like supposedly looking through this. This is obviously done in post production. So he's like swiping the air in front of his face randomly. But anyway, can you explain anything else? After all of that, we go down here. Is he gonna open it, close it? Okay. So I'm assuming that that most of you understood. That is a good question, Vinayak. Why use an inset instead of a basic, well, your pin hinge and things like that? You could put a pin hinge here, but the inset also provides certain additional benefits, which most of them have to do with structure. It is a much stronger thing than a regular pin hinge. Stronger for the size that it has and things like that, and it also has additional features, like, as in, you can get additional features like soft closing. Does anyone know what soft closing is? No, but the hinge could still be put in this line, no, as in between the door and the support itself, and the door will open. So it was a good question, actually. The slight pushy thing is correct. Yes. The the point of that is, you can try, as in, there are a few of these well, hinges that allow for you to basically push the door shut with whatever force you want, and it won't go and bang, right? So it'll go whatever speed all the way to maybe 5 to 10 degrees, and then it'll completely slow down and kind of auto close softly. So that's the soft close part of it. Yeah, what Vedant said also, exactly what I said. So so yeah, there are quite a few benefits of using these hinges. What's the same as a half overlay? The pin hinge. I just realized that as in, a few people said that their internet is kind of shoddy and things, so they'll watch this later, and none of them will be able to see the chat. I think, I don't know how that works in the recorded version of this thing. But yeah, no, Abhay, no, it is not a pin hinge. I mean, it's not a half overlay thing. Here, you can't put the pin hinge anywhere, right? As in, you can try and put it between this and the support and things, but it does not work. It might work here between the gap between the door and the thing. So in the inset is where you can possibly use a pin hinge, but yeah. Clip-on hinge is basically any of these. The idea is that it's easy to install and things like that. When I say easy to install, I don't mean the actual connection to the door itself. So the point is, these things come as separate pieces, and so you can what's this? Have like your carpenter, one carpenter sit and fix the hinges to the door side of it completely, and the other guy will sit and do the support hinge everywhere, and then they can literally just carry the door, go there, and snap fit it into place, or basically clip on into place. There are issues with trying to do that. Obviously, you have to align it and things, so it's generally the same person doing it. But that's the reason it's called a clip-on hinge. But yeah, assuming this part of this, well, wardrobe is understood, we'll get to the next part, which are as in which are drawers. So that's the second most important part of your, well, wardrobe, right? As in terms of hardware, anyway, in terms of usage, you have shelves, but more important, you have these drawers, and the regular drawer works like this. Okay, remember the shape of it. I'll Google a section in a second, but understand that this face plate, or whatever you want to call it, I don't know what the technical term for this is, but this particular piece is much wider than what is behind it, because it kind of covers the supports also. We'll get to the section and plans in a second, but this is how the earlier things were done. You basically have a groove cut into the draw itself, or something like that, and you have a wooden dowel or something like that just to hold it in place, and then it slides along that. There is enough and more friction thanks to wood on wood, And well, yeah, but we've been used to that. The issue happens when you have things like a chest of drawers or something which has a lot of heavy things in it. The chest of drawers simply won't open, or you have to struggle with it to open, because obviously more weight there is, the more friction there is. And so to solve this issue, we have drawer rails. Okay, and all of you have probably seen these and probably guessed this was coming, but these particular things, right? The idea of these is that this fixes onto your what's this thing called, the draw itself, and one section sticks to the support, and with things like rollers and ball bearings and things like that, the movement is much smoother, and well, obviously better. Now there are three types of these kind of rails. One is what's this? We call it a roller, right? A roller hinge is these things. So it literally has a roller on it, and on that roller is where the draw will kind of well settle and things like that. This thing rather this thing is what is stuck to the side of the cabinet. This is what is on the draw itself. So there are two sets of rollers. This basically runs in this track, right? So this is kind of the most basic version, the cheapest version. The next one is called a telescopic one. Eesh, drop something. Okay, a telescopic one are these things, slightly more complex, and they work basically. This thing will fix onto the support or the outside. This portion will stick onto the draw itself, and so as you open it, this all of these extend out well telescopically, and it supports. It's a little more expensive than the regular roller one. This is the next version. The third version is something called a tandem box. Yeah. So a tandem box are generally used for kitchens. So and they are as in the internal mechanism is much stronger and things like that, obviously. But basically it comes with this outer covering like that, right? So these are the more complex ones. These are the more costly ones, but these are the ones that can take the extra load of things like your of vessels. And assuming generally, actually, we'll do this in the kitchen sheet. But my general question is, how many kgs of rice do you buy at a time, or how many kgs of atta do you buy at a time, and things like that. In the Indian scenario, we generally tend to buy, as in the 1 kilo thing exists, and quite a few people do that. But on average, I'd say 5 kilos. There are quite a few people who do things like 25 kilos and stuff like that. So while designing kitchens, obviously, as in the size, and you have to speak to your client and figure out how they live their lives and stuff like that. But to store those things, we use a tandem box, and the tandem box they are rated for different weights and stuff like that. And yeah, so and yeah, technical details of all of them. Oh yeah, that's this I should probably mention to you. This is one of the cool things about using architectural hardware, and hardware that is easily available. Uh, we are literally just buying this and connecting this to our wardrobes and drawers and whatever else. Uh, so since you're buying them, it means someone else is manufacturing them, and they need to explain to us what preparations we need to do for to actually fix this in place, right? So thanks to that, who keeps 5 kg rice in a drawer? I've seen people. Isn't yeah. Just become an architect, man. All of these things are like, really, you do that? Why do you do that? But anyway, coming back to tandem drawers. No, coming back to architectural hardware. Since these things, since the manufacturers have to have us prepare for these particular things and design our wardrobes and things in a particular way, we get all these shop drawings. We get all these well PDFs of these things. Quite literally, actually, you'll probably get AutoCADs of them if you look hard enough. And these are the details that mostly go into your sheet, right? So that kind of helps. So yeah, just recapping, we have three types of drawers, as in obviously we have four types of drawers if you really look at it. The one without the rails at all, which is just your what's it, friction working. Actually, not fire; it just works and supports the thing itself. Then we have the yeah, we have the roller version. So one side of it sticks to the support, the other side sticks to the draw itself. And this particular thing runs in this channel here, and that kind of supports it. This is as in it's not very strong, and it's honestly not even very clean in terms of a finish or anything like that. So not very often used. The telescopic ones are the midway between the roller and the properly strong tandem. So these are the ones that we generally tend to use. These are also available in a lot of versions. Each company has its own lots of specifications, how much weight you need, how much as in how much it needs to extend, blah blah blah. And obviously these have like ball bearings and all sorts of mechanisms in there to make that thing entirely smooth. And then we have these tandem boxes. So this is what is fixed onto the support itself, and this is the draw, which moves along these, well, not really channels, that entire mechanism. I don't really know how that works, but yeah. Also, Bloom is one of the more famous versions of this thing. But the what's this? I'd suggest that you possibly look at something like a half lay, which I shall Google for you since I can do that. Right, so these people, uh, lots of images of, okay, half-play hardware, right? I should probably make this a little smaller so you can see the websites cleaner. Okay, little more visible. So country selected and all of that, products, man. Okay, India. Yeah, sure. Go to country page. Bharat. What? Seriously? This has nothing in it? Locations. What a crap. Halfway architectural hardware catalog PDF. Might as well. Catalogs, brochures, and apps. They even have apps. How cool is that? So yeah, catalogs. Yeah. Why don't? Why not? Compact. So yeah, so the different hardware things that they manufacture or deal with, and these are, and Halfley, as in, I'm asking you people to look up Halfley mostly because they have all of them, not because they're the best company, although as in, they are among the better ones in India anyway. But things like your handles, your pull handles, all the different types of handles, hinges, your pin hinges and stuff, and possibly your the inset overlay and things like that. Locks, profile cylinders are things that you actually should have learnt with your while you were doing glass partitions and glass doors in fifth, fourth semester, whenever. I don't know what this is. Mortising jig. I think this has to do with the actual carpentry of it. Jigs are generally drills and stuff like that. I'm not too sure about this at all though. Door control devices, opening, closing, panic exit devices, which are basically exit doors, or that opening thing for the thing. So all of these are the ones that we generally use, right? Patch fittings, point fittings, uh, and these catalogs have. Oh, this is the wrong catalog. Better versions have like complete well, drawings in them, not just the. Or is this a very old one? But yeah, uh, really master catalog. Hardware specification. Yeah, so at some point, somewhere, you'll get extremely detailed measurements and things like that online of how these things are fit, what the dimensions have to be, all of that. I'm pretty sure the catalogs themselves have them. I can't find it for now, but yeah, look for them. And with that, I think the wardrobes is kind of clear. Oh no, we haven't dealt with the sizes, as in sizes, heights, and stuff like that. Oh wait, what did Vinayak ask? What do the new ones use? Wait, what? Oh, those are just basically magnetic catches and stuff. Actually, I used that in one of my projects again, the same project really. I'll just show you that. This is still in yet to be finished, so it has paint all over it and things like that. But ignore that part. So these are push pull, as in basically magnetic lock, magnetic catch systems. So the idea is that this particular thing works on like that push pull thing, and it has a magnetic catch at the very end of it. I think I zoomed towards the door. Huh. So you have the just a basic metal plate there that actually well sticks to this, and that's it. The issues with these are that, as in, you do get much more fancier ones and things, but these are very, very cheap. The ones that I've used are honestly very, very cheap. This I've used for a loft that they won't actually use too often. So this will probably what die in some time, but it'll probably be a few years before it dies, purely because I don't open that loft too often. And the reason I did that is because I didn't want to provide doors and I mean what's this handles and things like that. So yeah, so these are the magnetic well catches. So any other questions, any other queries in terms of this? I'm also hoping that you know the sizes in terms of heights that you have to use, as in what's the height of all your shelves, what's the height of your what's this the hanger rail on top, blah blah blah. All of those things I'm assuming you get. Yes. Hmm. Okay. Uh, while you people are still answering that one simple question, this is what I meant. So you have your have the handle and everything, but you have very detailed drawings of this, such that as in it helps you people purely because you can put this into your sheets. It helps regular architects because we know what size the thing is and how big it has to be, what clearances are required, and things like that while designing uh, where the handle should be attached onto the door, what height, what width away from the wall, whatever it might be. So going down to another. I think you answered that didn't you? The 2 feet depth. Uh, Basically, it's the your hanger that kind of defines that width. But you have to realize that where let's go back to AutoCAD for a second. You have to realize that okay, I'm deleting these green doors. Let's assume that the blue one is our door. This thing. I'm just gonna randomly draw one there. So assuming these are three doors, that's our support. So it has to come up here. The shelf cannot come to this level, right? There has to be a decent clearance behind it. So that's let's say 3 centimeters, which makes your shelf depth 55. And, linear, right? 55.1 for some reason, but yeah, it's approximately 55 centimeters rather than your full 60 centimeters depth. And the issue is when you start using things like drawers. Okay, the plan and thing of your drawer is that the face or the absolute front of your drawer itself can come out only up to this line. After this, you have the handle. If you have like a lock and things, the key is going to stick out. So you have to leave clearance for all of that. So that's a good 5-6 centimeters also. And behind that is where the actual drawer will even start, right? So these kind of considerations have to be well thought of, but these, as in, you invariably realize these things as soon as you draw a single section, right? So does everybody get the entire sheet, so to speak? This was way longer than I anticipated it to be. But this is the sheet. This is Akriti sheets, but as in the photo quality and all of that is. Oh no, this is still WhatsApp image. Why am I on WhatsApp image? She sent them as. Ah, much better. Adjustments, exposure. Make this brighter, offset slightly. Yeah. And push the contrast maybe all the way up. Okay, let's just look at well the sheet that well 7C did. So this is your support and the hinges and the actual area as an in dotted line where the what cancel. So this is where the door would open to and things like that. In section, you'll have to realize that the what's this? Wait, is this a draw? So assuming this is the draw, there is a distance. I think this distance is a little too much, honestly. But well, there is that. These are the rails themselves that we are using. She's used the roller rails purely because it's a wardrobe and you don't really need the fancy fittings. Because yeah, it's going to be a sock drawer or something, so it's not going to have very heavy things, so we don't really need that. So this is perfect here. Uh, the ones that fit inside, the ones that fix onto the door itself. Then what are the details? A locking mechanism that she's drawn. I don't know what detail that is. Oh, this is the shelf fixing. Oh yeah, shelf fixing also has these. Basically, they are just clips. All right, let's Google them. Shelf clips. Basically, these kind of very simple mechanisms. Yeah. So the idea is that no, not that one. Let's look at something else slightly better. But yeah, there are tons of these versions, right? So the idea is that you screw this into the support, so the wall happens here. This one is where you, this as in the flat side is obviously on top, and you literally rest your shelf on that. The idea with this is the shelves suddenly become movable, or rather removable. You can remove the shelves if you don't want them, and one of the design ideas is to. Oh wait, I've done that somewhere. Do I have that? I close that. Okay, so the idea is that say you put these shelf things at every 6 inches and things like that, or 15 centimeters, and you put the shelf itself at every 1 foot or 1.5 feet, and say at some point they need one shelf which has a higher well height, then they could just move the shelf up and down and things like that. So there's that. So that's what she's drawn here, the plastic clips. In terms of the elevation, well, in terms of usability and things like that, you can design them how you want, depending on your client in quotes. Uh, in where we try as in the best way, I think, is to imagine a particular set of clients, so a family or whatever it might be, and based on their well usage or your understanding of their usage, design wardrobe. So what's this is a shoe rack at the shoe drawer, I should say, at the very bottom. Shelves on things. This is the as in she has a, I think, yeah, the hanger rod is here, and what's this? So that has a decent height. The height of these things are again standard, but you can obviously design for things like, assuming you have a lot of kurtas, a long kurtas or something that you don't want to fold, that you've ironed and you want to keep it like that, then yeah, you'll need a taller hanger space. And if you have, I don't know, just shirts, then you don't need that height and things like that. So all these things are standard, but still well customizable, if I can say that. Yeah, I think with that we can close it for the day. There's not too much else that you need to really see. The section you've seen. Oh yeah, at the very back of this thing, we have another sheet of ply, and that one's thickness, as in that does not do any supporting, that doesn't do anything. It's basically just like the backing ply. So 6 there is completely fine. The inside of a wardrobe, generally you have a cheaper laminate, because even the inside thing has to be finished, as in these surfaces and things. So my general go-to is to say off-white laminate on the inside, and off-white matte laminate on the inside, and on the outside or the doors itself, yeah, you go with fancy laminate, whatever particular design you like and things like that. You can even go with veneer, and yeah, design whatever you want with that. In terms of the height, I've taken from floor to floor. I'm assuming that there is no loft or anything like that, so I'm what's just going to design the doors as two separate levels. So what did I do? Also 210. So approximately at that level, I will have basically a cut there. These grid lines here. Yeah. So yeah. So this is kind of what the final elevation will look like with the doors closed. With the doors open, obviously it's a lot more complex, which is what she's drawn here. This is what the inside looks like. This is her is the elevation that she's drawn. So these are all with the doors closed, the handles, the locks, and things like that. So yeah, with that, I think we can close for the day. Any questions? Yeah, Gautam. Yes, this it what's this, there are like electronic things, there are motorized versions, there are lots of different things, and basically every week someone comes up with a new version of these things. So you can definitely, yeah, go Google them. You'll find invariably new ones. For now, we're trying to get at least the basics in place so we understand how they work, and then yeah, you can use whichever one you want. Yeah, this is Akriti sheet. There's a reason she doesn't need to butter me, man. This is that reason. Okay. For the rest of the sheets and stuff like that, I think this is way too long. This took what, an hour and a half. It really shouldn't. So I'll and now I have to start preparing for this stuff and all of that, man. This is, you people owe me, right? To figure out how, what, and all of that. But yeah, you people owe me. But yes, have fun, enjoy yourself. Hope you understood something and it was helpful. So thanks. See you soon. Bye.